All right, in this video we are going to work through problem 5.80, parts A, B, C, actually all parts on this one. All right, so multiple choice exams. It says a student takes a multiple choice exam with 10 questions, each with 4 possible selections for the answer. A passing grade is 60% or better. Suppose that the student was unable to find time to study for the exam and just guesses at each question. Find the probability that the student A gets at least one question correct. Okay, so this experiment here, right? Success is guessing the answer to the question, right? So that's basically the experiment we have. We have 10 questions. Those are like our 10 trials in this problem. Okay. And so a success, right, is guessing the answer correctly. So guessing correctly on a question. All right, so that's what success will be on this. And then the probability, right, of a success is, let's see here. Okay, so each question has 4 possible selections, right, for the answer. So that is 4 answers and there's 1 correct one, right? So the probability that you would guess on any single question, right, is 1/4. I'll just write that as 0.25 as a decimal. Okay, so the probability of a success is 0.25. All right, and so this is a binomial. The number of questions that are guessed correctly out of 10, right, is the number of successes, right, is a binomial random variable. And so in order that we have the formula right here that we can use to calculate the probability of events. All right, so part A, right, is the probability that they get at least 1 correct. Okay, so there is a couple of ways to do that, right? One way to do it, and now this is not a good way, right? But if they get at least 1, and I'm just going to erase this after I write it, but I just want to show you this, right? So this would be the same as the probability that x equals 1, right? If they get at least 1, that's 1 or more, right? So if they get 1 correct, or they get 2 correct, or they get 3 correct, or, right, and then just keep going, right, or x equals 10, like this. Okay, so that's one way you could do it, and you can see that's going to be a lot of calculations, right, to have to do that. So that is not really the way that you want to do this problem, right? And the way that you want to do this problem is to use the complement rule, and you'll find that a lot, right, with problems that say at least 1. Okay, if it says at least 1, right, then you might want to try using the complement rule, right? So the complement rule says the probability that you get at least 1 correct, right, is 1 minus the probability that you do not get at least 1. So that's the complement rule that we studied in the chapter on probability. Okay. Okay, so then the probability that if you do not get at least 1, well, that only means one thing. That means you got 0 correct, right? So that would be the same as 1 minus the probability that the value of the binomial random variable is 0, right? So 1 minus the probability that x equals 0. So this way is much more efficient, right? And the other way that I was showing you at the beginning, you'd have to plug in 10 different numbers, right, into the formula, and then get those values, and then add them all up. Okay, and now it's pretty easy with Desmos, but still, it's not the way that you want to go about it. Here, you have to only plug one number into the formula, and actually, really, you don't even kind of have to do that. It's really easy to plug 0 into this formula, but we'll just kind of do it the long way. And then all you have to do is subtract. So that's it, okay? All right, so let's work on our formula here. Remember, this is our formula over here for the binomial random variable. N is the number of trials, and P is the probability of success. All right, so let's see. We know that P is equal to 0.25 in this problem, right? That's the probability of success. So that's P. And then N, I think, is 10, right? There's 10 questions, right? So 10 trials in this experiment. But let's double check that. Yeah, 10 questions. Okay. So that's what it is. All right. So again, I recommend just using Desmos, right, to calculate this out if you can on your test or on your homework, right? And then you get NCR. That's for this binomial coefficient. And then N is the number of trials. That would be 10. And then leave the X in there so you can plug in the X's. So write it as P of X equals, right? And then it's P, which is 0.25 to the X times 1 minus 0.25 to the, and then in parentheses it's going to be N minus X, which is 10 minus X. All right, so P0 would be 0.56, right? But what I really want is 1 minus 0. So you could just write this down here and subtract, or you could just do this, right? On Desmos, you can just put 1 minus P0, right? And get your answer there. Does that look right? Oh, yeah. Okay. All right, so on that part, we get 0.944, it looks like, for the answer on that one. Okay. Okay, next part is B. It says, what is the probability that they pass the exam? Okay, so pass means at least a D, right? So assuming they all count the same amount, what's the probability that they get at least 6? Correct. Okay. So if you got at least 6 correct, that would be the probability that X equals 6, or the probability that X equals 7, or probability that X equals 8, or probability that X equals 9, or the probability that X equals 10. All right, here we have the or of a bunch of events, right? And so we have to ask ourselves, are these events mutually exclusive or not? All right, could it be that you perform this experiment and you get 6 correct and also get exactly 7 correct? Right? No, that's not going to happen, right? So all of these events are mutually exclusive. So what that means is that you can use the special addition rule to calculate the probability here. So it's going to be the probability that X equals 6 plus the probability that X equals 7 plus the probability that X equals 8 plus the probability that X equals 9 plus the probability that X equals 10. Okay, and so you would plug those into the formula and see what you get and add them all up. Fortunately for us, right, we're using Desmos, so we can just punch in the expression like so, right? We can do probability of 6 plus P of 7 plus P of 8 plus P of 9 plus P of 10. Oops, 10. Okay, and so you can see we wind up with this value here. All right, and let's see, maybe I need to make that slightly bigger. And so we wind up with 0.0197 on that if we go to 4 decimal places there. Okay, so not a very big chance that you will pass if you just guess. Okay, it's pretty small. All right, so next up is part C. What is the probability that the student receives an A? 90% or better. All right, so to get an A, right, that would be the probability that you get at least 9. Correct. All right, so that would be the probability of that x equals 9, right? Or probability x equals 10. And like we keep doing in this section, right? We say, hey, these are mutually exclusive. You can't get 9 correct and 10 correct at the same time. So we can use the special multiplication rule, or addition rule rather. And these can be added together, okay? And so plug those in to our formula. So that'd be the probability of 9 plus probability of 10. All right, and that is a really small number. No. All right, so here's the number that we get, and that would be what, 1, 2, 3, 4 zeros and a 3 if we round it off. So that would be 0.00003, right? So that's again extremely low probability that you would get an A by guessing. Okay. All right. Next up is it says part D. How many questions would you expect the student to get correct? All right, and so that one would be the expected value or mean, right, of this binomial random variable, right? And we know the formula for that would be n times p. So n is 10 and p is 0.25, right? So when you multiply that out, you get 2.5. So on average, right, the more and more, if we did this as an experiment, right, we gave people this test and said, just guess. So basically, we just gave them the answer sheet without answering without the questions, and they just filled out the answer sheet, right? We would expect that in the long run, right, the average number of questions that people get correct would be 2.5. Okay. All right. Next one is part E. All right. In part E, they want to know obtain the standard deviation of the number of questions that the student gets correct. Right. We know that this is a binomial random variable, so we can use the formula square root of n times p times 1 minus p, right, to calculate the standard deviation. So when we do that, that's going to be 10 times 0.25 times 1 minus 0.25. Okay, and so we can calculate that out. And 1 minus 0.25 is 0.75. All right, and so we get 1.369 to 3 decimal places. All right, and that is it on this one.